Hello there, Integrated Algebra students. This is Mr. Zacek. We're beginning a new unit here, Unit 13, which is on statistics, which is the study of numerical data. And today we kind of have four areas that we want to cover. So I'm going to try to get to it right away. And a lot of this is about vocabulary. So we really need to pay attention to these terms. They're very important, and you're going to be um, you're going to need to know them and be able to recognize the difference. The first is that we can qualify data as qualitative or quantitative. We can separate it into those two things. And when you look at the word qualitative, and if you look at the beginning of the word um, quantitative, we get with qualitative the word quality. And so when we're talking about qualitative uh, data, we're talking about data that deals with descriptions and it's observed but not measured. So observed but not measured. Some examples of um, qualitative data would be like the color of something, the texture. It could be the textures. It could be how it smells. It could be the taste. It could be the taste as an E. Could be the beauty of something, etc. Those are all qualitative descriptors. Well, quantitative, the root word here is quantity. And when you think about a quantity, you're thinking about a value. So this here deals with numbers. When we have quantitative, we're talking about numbers. And it's data which can be measured. So data that can be measured. And you really want to think with quantitative, we're looking at things like the length of something, the height, um, area, volume, weight, etc. Okay, things that we can measure with numbers. All right, so a couple examples just to illustrate the difference between these two. A restaurant asks customers to rate the meal that was served as excellent, very good, good, fair, or poor. Well, that is a qualitative measure because it's not a number, it's a quality of it. A restaurant makes a record of each customer tip at different times in the day. That's a quantitative. The tip is going to be a specific amount. So let's try a few of these here as we go through. State whether the given phrase represents quantitative or qualitative. A person's middle name. Well, that's going to be qualitative. All right, it's not a number. The number of hours spent studying for an exam. Quantitative. It's a quantity. All right. A person's hourly wage. Quantitative. The texture of a person's hair. That's going to be qualitative. A person's gender. Qualitative. Again, it's not a number. Person's speaking. A person's ethnicity is going to be qualitative. The language a person speaks, that's going to be qualitative. I think I didn't spell that right up there. And E. The distance a person drives to work, that's going to be quantitative. Okay. Person's test score, again, measurable number, quantitative. All right. So hopefully you see the difference between those, and you could go and finish the rest of those for a little more practice. But the first thing we have to understand is the difference between qualitative and quantitative. All right, so we're going to flip the page here. And the second thing that we're going to look at is univariate versus bivariate data. So if we look at this prefix here, univariate, if we think of a unicycle versus a bicycle, it's kind of going to give us the distinction that we have here. In a univariate, we're dealing with 1, and with a bivariate, we're dealing with 2. So now variate is like variable. So when we have univariate, it's a single variable, and it's usually an analysis to describe something. We sold 100 hot dogs. Bivariate is 2 variables. And when you have bivariate data, we're usually looking here at analysis to explain. Okay, did one thing cause the other one? All right, or are they related? Okay, so in univariate data, this does not, okay, deal with cause or relationships. Okay, because there's only one value that we're looking at, one variable. Bivariate does deal with cause or relationships. So univariate, again, one variable. Bivariate is going to be 2 variables. So we're just going to look at a couple of these. The times in seconds of 20 students running the 100-meter dash. Well, all we're looking at is their times. All right, and so that is a univariate. I'm just going to write the prefix. The mean score on the last math test. Univariate. That's a single measure. The number of push-ups done by 40 women after X weeks. So we have the number of push-ups, X weeks of strength training, that's 2. There's our bivariate. The month of the year and the cost of a hotel room, bivariate. A lot of times when you see the word and, that's an indicator that it's bivariate. But as you see in C, it's not always true. Sometimes you don't have the word and. Okay, E, the number of rooms in a house, that's a univariate. Okay, it's going to describe. F, the number of absences from school and a student's GPA. So number of absences, student's GPA, bivariate. So we might be trying to look, is there some relationship there? G, the number of miles 40 people drive to work each day. Okay, again, this one, number of miles people drive. Just because it's 40 doesn't mean it's bivariate. That's a univariate. Okay. Now, when we're looking at stats, one of the things that comes to be really important is the presence of bias. And we need to understand this sentence right here, that poorly designed sampling techniques result in bias. So we're presented with data all the time. If you watch the news, any given day, they're telling you some study, the survey says, 42% of the people approve of the president, or, 56% of the people feel that this is, strongly important. All the time we're being presented with that information. What we aren't always presented with is the bias in the sampling. So, for example, if the president is Democrat and they only ask people who are registered Democrats about their feelings, obviously they're going to tend to have a higher opinion of the Democratic president. And Republicans would tend to have a lower opinion. So, and then vice vice versa. If it was a Republican, they tend to, Republicans would tend to favor them. So we want to try to avoid bias when we're collecting data, when we're trying to take a survey, or maybe we're trying to get students' opinions about after sports. And so, well, if you only ask people who are on the sports teams, what would happen? Well, they would have probably an opinion that would be stronger in favor of sports than the general population. So we want to avoid bias, okay? So we want to try to avoid bias when you are using sampling. So we look at a few things. Who collected the data? Is it a recent study? What is the sample size? Does the sample contain a different reasonable number of people being tested? Now, sample size, that just means like how many people. And you want to try to have a random sample. This is what we're looking for in studying. Now, the reason it's a sample is it's hard to get everybody's data. So, it would take a long time to survey the hundreds of millions of people in the United States, but with some methods, we can only take a small sample, and usually, if it's done right, that sample represents the larger population. So here we have some instances just to help us understand this thing. In each case, a sample of students is to be selected, and the height of each student is to be measured to determine the average height of a student in high school. So here's what we're trying to determine, the average height of a student in high school. For each sample, tell whether the sample is biased or unbiased. If the sample is biased, explain how this might affect the outcome of the survey. Okay. So A, again, remember, what are we trying to get? The average height of a student in high school. So the basketball team. Well, I think that's bias. Why? They tend to be taller. People who play basketball tend to be taller. So that's going to skew the data. The senior class. Well, that has bias. Why? Because they're older. And so therefore they would also tend to be taller, just an age thing. All 14-year-old students, again, that has some bias. What about the 15 and 16 and 17-year-old? And they would tend to be shorter. Okay. All girls. Well, that also has bias because it's going to be girls tend to be shorter than guys on average. So if we're trying to get the average height of a student in high school, we don't want just the girls. Every 10th person selected from an alphabetical list of students, that to me sounds like an unbiased sample. Okay, it's random. It pulls from all the students, so you're going to have all the grade levels, and you could get a good idea of what that would look like for them. All right, let's try number 2. A reporter surveys people leaving an ice hockey game and asks them whether they agree that the rink is old and run down and should be destroyed to make room for a shop smart store. Why might the data and this reporter collects be biased? Okay, well, if they're trying to tear down the hockey rink, the people leaving probably aren't going to be too happy because they may want the hockey rink to stay. So that might not really represent the community. It might just be a small portion of people, and they might have a negative view about the store in that instance. Who knows? Maybe the whole community does. You don't know, but it's likely that that is a biased sample. Let's do one more. Every student in the senior class at Kelly High School has their name placed in a hat. 330 names are then chosen from the hat, and those students are given a survey. A cash prize from the yearbook staff is awarded once the survey is filled out. Survey results, which include favorite teacher, favorite subject, etc., are then published in the year's yearbook. Do you believe the results will be valid? Well, they're putting a lot of people in there. The whole school, everybody in the senior class has their name, and then they're drawing a large sample size. Okay, so this is a fairly large sample. That's a good thing. All right. What else do we have? It's random. You know, they're just pulling it out of a hat. So do you believe that these will be valid? Yes. Okay. They have a large representative sample randomly drawn. Okay. So you just want to be able to defend your argument um, one way or the other. Okay. Let's do one more. Number 4. Every 10th customer who enters Pet Lovers Pet Store is asked whether they believe that the penalties for animal cruelty should be more severe. Do you believe this survey will result in a biased or unbiased data? I would say bias because, you know, they'll probably tend to have stronger feelings towards pets. You know, just because by virtue of going to a pet store, they're probably going to spend some money, you know, just as an example. Okay, the last one here for today is correlation versus causation. And when you see the word correlation, correlation means something is related to the other. So if there is a correlation, it's related to the other. But a causation is when one causes the other. All right. So sometimes things can be correlated, but it doesn't necessarily mean that there is a cause for that. Let's look at some examples. The longer you walk, the more distance you go. Okay, well, that's a cause. Walking causes you to go a further distance. If you press the button, the bell will ring. Well, that's a cause relationship. Push the button, it causes the bell to ring. The more you study, the better grade you will receive. Now that is a correlation. Now it doesn't cause you to get a better grade per se, but there tends to be a correlation between those two things. The more it rains, the higher the lake becomes. Well, that's going to cause, rain is going to cause the lake to rise. The more you smoke, the probability of getting cancer increases. Um, Again, that's a correlation. It doesn't cause cancer, but there's certainly, maybe in some instances, but it definitely correlates. The more food you eat, the more calories you ingest. That's a cause, right? Eating causes you to have more calories, right? And that's not necessarily bad. That can be a very healthy thing for you. So there are both positive and negative correlations. Positive, as one increases, so does the other. Think about your slope lines. And negative correlation, as one increases, the other decreases. So here we go. The more a baby is held, the less he or she will cry. So this is a positive correlation, negative correlation. Very similar to slope. Okay, a lot of stuff there. 4 key areas for you to look over and to really, you got to be confident with: qualitative versus quantitative, univariate versus bivariate, looking at something as biased or unbiased, and the last one here, correlation versus causation. All right, if you have any questions, please ask those in class, but good luck with this. Thanks. Bye.